Hey everyone, it's Ken here again. One of the really cool things about Power Query is that there's actually 9 different ways to join data. And this is obviously a very big change over what we're used to in Excel, where we had VLOOKUP to pretty much say, is it there or is it not? So the first join type that you're going to be familiar with is going to be the left outer join. This is typically very similar to what the VLOOKUP exact match style join is. And if you look at the examples here, we have a transactions table and a chart of accounts table. The red records in the transactions table don't have account department combinations that match in the chart of accounts, and the yellow records in the chart of accounts don't have combinations that match in the transactions table. So the left outer join would give us all the records from the left table, and it would only return the matching items from the chart of accounts table on the right. We also have the ability to look the other way using a right outer join. That would return all of the items from the right-hand table and return only the matches from the left. We have a full outer join that will return both sides of this join type, showing us holes where holes exist. There's an inner join as well, which will allow us to see only the blue and white records, only the ones that match, so ignore all of the yellow and red. We've also got something, and this is a really great join, where we can actually find mismatches from one table, both from the left and the right. And if we actually work our cards right, we can even build a specific join type called a full anti-join, which would allow us to find just the things that don't match. And that's probably actually one of the most useful joins at all if you're doing things like bank reconciliations or you're trying to figure out the difference between two lists. The Power Query team decided that we need a couple more, the left semi-join and the right semi-join. Let's look at each of these join types in a little bit more detail to see what you would actually get. First is the left outer join. This is the default join. What this one should return is everything from the left-hand table and only the matching items from the right-hand table, filling in any gaps with nulls or empty cells. And as a matter of fact, that's exactly what you're going to get. Now, I've highlighted the records for the red that show up here, and you'll notice that we can see from the transaction side of the table that we actually have the transactions, but on the chart of accounts side of the table that got merged in here, it's showing null values for the accounts of 64015 from Department 150 and 64010 from Department 350. So that works out quite nicely. The right outer join looks at things from the different way. It pulls back everything from the right-hand table and looks for the mismatches on the left-hand side. The full outer join actually pulls back everything from both tables, so you can actually see where the holes are in the data. So this is kind of useful because you can start seeing what's not matching up as well as what is. The inner join returns the matching records from both sides. So you'll notice here we see no red, we see no yellow records whatsoever. We only see the things that are actually cleared across as, yeah, these exist in both tables. So that's good to know. Then we have the left anti-join. So if you're into exception pattern matching, this is really cool because this will pull back just the items from the leftmost table that don't have matches. And likewise, its cousin is the right anti-join, which will allow you to get just the yellow records. There's one more join type to look at, and that's called the full anti-join. So if you're doing any kind of a reconciliation, this is probably the most important join type that there is because it pulls back and says, what are the exceptions that we're looking for? What are the things that did not match? Unfortunately, this is the only join type that Power Query does not provide by default, and you have to build it yourself. The secret though, actually not that hard. You build your left anti-join, you build your right anti-join, and then you append the two together. So it's not too difficult to build. It's just that you have to know you need to do it. It's unfortunate there's no default for this because it's such a useful join if you're doing any kind of reconciliation work whatsoever. I'm going to introduce you to the left semi-join. Before I do that though, I want to quickly review the left outer join to show you what's similar and different between these two things. Our left outer join would return these records. Now, the reason it gives us these ones, of course, is because it's looking at all records from the left-hand table, whether they have a match in the COA table or not, but it's not going to find anything from the COA table unless the item exists on the left. Of course, it's going to give you a new column called, in this case, COA, because that is the actual name of the table, and it contains a bunch of tables, which, when we expand say the name column out of them will give us this. So we've got the account name where we have an account department combination that exists in the COA table, and where we don't, in the case of 64015 and so forth, we get null because there is no matching record. So that's our left outer join. It's very, very useful for sure. Now let's take a look also at the left anti-join, because the left anti-join, of course, has a different purpose where we're saying just find me the records in the transactions table that don't have a match in the chart of accounts table. So in this case, we get back these two records. Of course, we've got the COA column here, and if we were to go and expand the name column out of it, we come up with nulls because there are no matching records. So again, a very, very useful join. But what if you only wanted the white records from the left table? How do you get that? Well, I mean, you could certainly run through a left outer join, expand your COA.name column, and filter out the nulls. That would definitely work. But the Power Query team added another join type for us, which is called the left semi-join, which gets us most of the way there. So here's the concept of what this one does. Is when you apply a left semi-join, you get a table that looks like this. So notice just the white records. We don't have anything that doesn't have a match in the other table, which is great. That looks perfect. But there is a big difference here between filtering the null values out of the COA.name column in the left outer join and what you have here. You'll notice that when I expand the COA.name column here, we have no values. This just comes back with nulls. So it's very much like the left anti-join, and that really the COA column that we create in both the left anti and left semi-joins, we can immediately delete because there's never going to be any values in it. So the concept here, like the left anti, is basically saying, just tell me what records either have a match in the case of the left semi or don't in the case of the left anti. And that's all the information I need. I don't care about what the offsetting values are. If I do care about the offsetting values, I need to go back to that left outer join, make the join, expand the column, and filter the nulls out. So we still have the ability to get that information with account names. We just have to use the left outer join if that part is actually important to us. In some cases, though, it won't be. And that's where the left semi-join can become super, super useful. As you might expect, to go with a left semi-join, there's also a right semi-join. So let's quickly go through the same process. We'll just remind ourselves what the right outer join looks like. When we apply that join, we get tables that look like this. So the key thing to really recognize about this one, while we get yellow records, the ones that don't have a match in the transactions table from COA, the left-hand side of this diagram is still predicated on the values that actually do match to the COA table. We just end up with one more row that says null, null, null for all the items that are in COA that don't exist in the transactions table. Now, as you would expect with this one, when we go and we expand the name column out of COA, we're going to get the extra values we have. Revenue special and rentals pull card should both come into play here. So we're going to get both those records. So we now have two that go null, 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 with the actual names here that we're looking for. Let's take again a look at the right anti-join. So the right anti-join always shows up like this initially. Null, 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 null. Freaks a lot of people out because they don't know why have I got a one row result with just a table at the end. But then when we go and we expand the final column and extract the COA.name out, what do we get? Well, we get revenue special rentals pull card, because those were the only two items in the COA table that didn't have a matching offset in transactions. All right, so what does this look like when we start playing with the right semi-join? Remember, the point of this is to try and get the opposite of the right anti-join. So when you start with your right semi-join, it's going to build a table that looks like this. Once again, null, null, null table. Just as freaky as that right anti-join starts out. But when you go and expand the records, what you get is you get all four of the individual items that you're looking for. Now, what's interesting about this one is that this one here, to me, is probably a lot more useful in these cases because I'm really just trying to identify the things that are on the right-hand side, and I've got a goal for that. But again, remember, the big thing here, there's no values from the left-hand table that are included in this. So when you go and you actually build one of these, again, whether you're using a right anti or whether you're using a right semi-join, after you've created a join, you're probably going to grab that column of table. you're going to right click, say remove other columns because everything's going to be null anyway. And then you can expand this to get just the values you want. Once again, if those values are actually important to you, you would build your right outer join and then you'd filter any of the columns to remove the nulls. And at that point in time, you would preserve the original data from the left table with the matches from the right-hand side. Now, as cool as these joins are, there's one little drawback is as I record this video, they don't exist in the user interface. So you actually have to create these manually. The good news is it's not as hard as you think. So in order to build your semi-joins, I'm just going to run a comparative here for your left and right semi-joins we go through. Basically, what you're going to do is you're going to set up a standard join using a left or right anti-join as needed. Once you've made your anti-join, you're going to edit the formula in the formula bar, and you're going to replace the join kind. Instead of left anti or right anti, we're going to switch it out to left semi or right semi. Okay, so basically you're changing the word anti for semi. Then, once you've got that done, you're going to go and right-click the new tables column. So in the case of the example I was just working with was COA, you'd right-click that, and then the action you take depends on which join you're working with. If you're working with the left semi-join, you're just going to choose remove column. If you're working with the right semi-join, though, you're going to choose remove other columns. And then for the right semi-join, that means that you'll be left with one column that needs to be expanded. So you're going to do that in order to get the records that you actually need.